Welcome back to our lesson practice review. Today we got chapter 2, lesson 10. To summarize what happened in this lesson, we're really focused on multiplying equivalent plus bi. So a couple ways to do this we've seen before. It's very similar to multiplying just binomials here. There's, kind of the FOIL method where you first outside, inside, and then last to get all the four terms, and then you combine like terms. The newer part of this is that we have I squared, which we know I squared is equal to -1. And so this minus 12I squared here becomes minus a -12, and then that just becomes addition. So the other method is to use the box. This is primarily what I will use just because it's easier to show when I'm going through that work, but it ends up getting us the same thing. We just end up having to deal with this I squared, which then kind of switches the sign. So for number one, which expression is equivalent to 4i times 2 plus 6i? I'm going to distribute that to get 8i plus 24i squared. And now this I squared equals -1. So it's 24 times -1. 8i minus 24, and then we want it in the order where our real number is first, so that just becomes -24 plus 8i, which we see is letter C. Problems 2 and 3, we're going to be using the expression 32 plus 4i. So for number 2, select all the expressions that are equivalent to 32 plus 4i. So we're going to have to kind of go through each of these to multiply out and see if they are equivalent. So for A here, I'll go ahead and do some different colors. So for A, I'm going to use a box, multiplying 2 minus 6i, 1 plus 5i, 2 times 1, 10i, -30i squared. The reason I like the box method for these especially is because when I'm going through this, the -30i squared ends up just becoming +30. I can kind of like change that before I start adding everything together, because basically each of the corners are going to add together, right? 2 and 30 is 32, 10i and -6i is 4i, and so we see that, yes, A is equivalent. For B, we're going to distribute, give me some space here, into here, so we get 4i plus 32i squared. In this one here, we end up getting a I squared, which makes this negative 4i minus 32, which when we switch that around is not equivalent because this 32 is negative. For C, there's a couple of steps on here. First, I'm going to distribute this 4 in to get 20 plus 4i minus 12i squared. The 12i squared becomes just 20 plus 4i minus a -12, which is the same thing as adding 12. Combining like terms, 20 plus 12 is 32. So I would say that C is also equivalent. For D, I'm going to head back to the box over here. We got 2 plus 2i, 9 minus 7i. 9 times 2 is 18. We got 18i. We got -14i. And then lastly, -14i squared, which this one here just becomes +14 because the negative and the I squared end up canceling out. And then when I add these corners here, 18 plus 14 is 32. -14i, +14i is just +4i. And so yes, D is also equivalent. And last but not least, going through I here, I'm going to start with the box, and then I'm going to subtract 4i when I'm done. So 2i, 8, -8i, 16, 16i, -16i, -16i squared. And when I add all those together, first I'm going to go ahead and make this +16. So when I add these, I get 32. When I add these together, I get 0, which is just 32, which means that this is not equivalent. So our answers for number 2 are A C, and D. Fill in the blanks to write another expression that is equivalent to 32 plus 4i. So lots of different possibilities here on this. When I'm focused on this one here, I know that when I distribute to here, I'm going to get something I squared, right? Which is just going to be a whole number. When I distribute into this one, I'm going to get my I. So I'm going to choose 2 for this first number because I know 2i times 2 will give me 4i, which is what I'm looking for. And then I want to put here negative 16 because when I distribute that, I get plus a negative 32i squared, which the I squared and the negative cancel out here, giving me just 4i plus 32, which when I rearrange, match up just perfectly. So I put 2 in the first spot and negative 16 in the second spot. But there's lots of different answers that you could do, I think. Actually, that may be the only one, but I don't know. You could surprise me. All right, problems 4 through 6. Rewrite each expression in the form a plus bi. So we're really just kind of simplifying these ones. When I'm squaring something, it means I'm multiplying it by itself. So I'm going to go ahead and use the box here. And I get 25i squared. This ends up becoming negative 25 because I squared is negative 1. When I combine that with a positive 1, I get negative 24. Adding these together, I get plus 10i. For the next one, I'm going to distribute this I to get negative 4i plus 3i squared. This ends up becoming a negative 3. And then rearranging negative 3 minus 4i. And last one over here for number 6, we got 9 minus 2i, 3 minus I, 27, negative 6i, negative 9i, and positive 2i squared, where this ends up becoming a negative 2 because of the I squared. When I combine it with the 27, I get 25. And then I combine these two, and I get negative 15i. So my final expression, 25 minus 15i. All right, problem 7 and 8. Here are two expressions, a plus 2i and 4 plus bi. Determine the values of a and b, so the product of those two. And then for number 7, it asks us, is a positive integer. So we have to do these two things here. We're going to go and 4 and something I. So is a positive integer. There's, I think, multiple answers that we could plug in here. But when I'm going through this, I need something to go here. I need something to go here. So when I'm doing that, what I need to make sure is that I could technically, I'd probably want to plug in a negative number here because I know that when I multiply that into this spot right here, then I get a I squared, and I want it to be negative so that that I squared and the negative cancel out. So I'm going to pick something like negative 4 here to see if that ends up helping us. So we'll plug that in and we'll see if it works out for us here. The thing about this is that we want to make this next number smaller here because I want to make sure that it evens out so that I get a positive integer. So something smaller like 2, we'll try that here, and then we'll actually get our answer here in green. So that gives us 8 in the first box, 8i in the second box. And then when I do this, I get negative 8i. Oh, there is only going to be one possible answer here. So I think a key thing that I kind of left out here is that the bottom left and the top right box have to be the same because we want it to just be an integer. So they have to match up to be negative 8i and positive 8i so that these end up becoming 0. Negative 4 times 2 is negative 8i squared. And then when we do this, we get 8 minus 8i squared. But this part here, the negative and the I squared cancel out, giving us 8 plus 8, which gives us a positive integer. So 2 and negative 4 work here. For number 8, has only imaginary parts. So that means that when we're doing this box here, and we got 2i, we got 4, and we got I, that means that the top left and the bottom right have to cancel out here. And so the only way to do that is that we have to match this up. So this has to be 2 and this has to be 4. So that way this ends up becoming 8 and this becomes 8i squared, because then when we add those two together, they will end up going away since the I squared makes this negative. What that fills out, so this is 2 and this is 4. That fills out to be, we got 8i, and then when we combine these, this 8i squared becomes negative 8i, so they cancel out, leaving me with just 8i plus 8i, which is 16i, and so we get just the imaginary parts. For the spiral review, problems 9 through 11, write each expression in factored form. So this first one here I see only has 2 terms, so I'm just going to use what I know about greatest common factor to pull that out. Looks like they're both divisible by 3, and they also are both divisible by x. So if I pull out a 3x, what would be left over on this first term? If I divided it by 3x, I would just get x. If I divided this by 3x, I would end up just getting 2. So after I pull out the greatest common factor, I have my factored form. Again, to double check that one, if you wanted to see if we get back to the original, we just distribute, because the greatest common factor, pulling that out is the same thing as the opposite of the distributive property. The next one here has 3 terms, so I'm going to try and throw it into my box. First term, first box. Last term, last box. -7, I have to break up into 2 pieces that multiply to 10x squared. So that would be -5x and -2x. Then I got to figure out what goes on the outside, which is x and x, -2 and -5. So the factored form here would be x minus 2 times x minus 5. And last one is the same thing. I got 3 terms here, so I'm going to try my box. First term, first box. Last term, last box. And then middle term here of x needs to multiply to -42x squared. Remember, that's me multiplying this first and last term. So that would be -6x and 7x. That goes here. Looks like 2x and x, 7 and -3, which then gives me my factored form here of 2x plus 7 times x minus 3. Good to get practice on factoring. We're going to do it a million times this year. So, and remember, key thing here, an idea is that the I squared here becomes a -1. That's really kind of the main thing when we're going through these to help us answer the stuff from lesson 10. Next up will be lesson 11, our final lesson for chapter 2.